Hello everyone. In this video we want to explain two Python programs developed in Tony based on chapter 11, Real-Life Applications of Computer Vision, from the book Raspberry Pi Computer Vision Programming. This chapter is focused on practical applications of computer vision where image processing techniques are used to solve real visual problems. In our case, we selected two examples that are clear and easy to demonstrate: the max RGB filter and the chroma key effect. The first program shows how the dominant color of each pixel can be emphasized, while the second program shows how a green screen background can be removed and replaced with a completely different image. These are both very useful examples because they connect computer vision concepts with real digital media applications.
The first program was developed to demonstrate the max RGB filter on a static image. The idea of this filter is simple. For each pixel, the code compares the blue, green, and red values. Then it keeps only the channel with the highest intensity and sets the others to zero. This means that each pixel is simplified so that only its dominant color remains visible. In the code, the image is first loaded with OpenCV, and then the three color channels are separated. After that, the maximum value among the three channels is found for each pixel. The code then modifies the channels so that only the dominant one remains active. Finally, the channels are merged again to create the filtered image. To make the comparison easier, the program displays the original image and the filtered image side by side using Matplotlib. In the results, we can clearly see how the max RGB filter changed the appearance of the image, and the original image contains mixed and natural colors, but after applying the filter, the colors become more poor and more intense because only the strongest color channel is preserved in each pixel. For example, the sky becomes a stronger blue region, the vegetation remains strongly green, and the car and the roof become more clearly red. This makes the overall image looks less natural, but it makes the dominant colors much easier to identify. So this first program shows that the max RGB filter is useful when we want to simplify the chromatic content of an image and emphasize the main color contribution of each region.
Thank you. The second program was created to implement a chroma key effect, using a foreground image with a green screen and a replacement background image. First, the code loads both images. Then, the replacement background is resized so it matches the size of the foreground image. After that, the foreground image is converted from BGR to HSV color space. This step is important because HSV makes it easier to isolate a specific color range, especially green. Next, the color defines a lower and upper range for green values and creates a binary mask using the inRange, inRange function. This mask identifies the green parts of the image, which correspond to the background that we want to remove. Then, the code extracts the new background only in the green regions and preserves the person in the regions where green is not present. Finally, both parts are combined to create the final chroma key result. The program displays the original foreground image, the replacement background, the green mask, and the final result. In the results, the green mask shows that the background was detected correctly, while the silhouette of the person remained separate from the green region. Then, in the final chroma key result, we can see that the original green screen was successfully replaced by the new city background. The person remains visible in the foreground, and the composition looks clear and coherent. This result shows that chroma key can be implemented effectively using color segmentation in HSV and simple image combination operations. It also shows that a uniform green background makes the segmentation progress much more accurate.